Hi again. In the previous video, we explored the debugger window, including how to set breakpoints and inspect or modify a running program. I demonstrated these features using a program that reads data in from a CSV file, updates it, and then writes it back to the file. If you missed that video, I recommend watching it first, as today we will continue using the same example. Today we will focus on conditional and unsuspended breakpoints, debugging third-party library code, and debugging lazy values. This content is inspired by Egor Ushakov's talks, IntelliJ IDEA Debugger Essentials, Debugger Advanced, and Debugger Professional. For deeper insights, check out the full talks. The links are provided in the description. I refactored the program to make it testable with munit. Originally, it relied on three side effect methods: read, ask for update, and write. For unit testing, I replaced these with functions passed as class parameters. In this test, the read function returns a predefined list of strings. Ask for update returns a number, and write stores data in a variable. Both ask for update and write also increment counters, so we can verify that they are called exactly once. The test passes, the output matches expectations, and both counters are set to 1. But to better understand the production code, I could set a breakpoint and use step into as shown in the previous video. However, this approach doesn't scale well. Debugging complex programs this way can be time-consuming and hard to follow. Another way is to sprinkle the code with log statements, run a test, and read the output. For logging, we will use slf4j. I created a logger instance here and the companion object, which I use in the run method to ensure that the intermediate results are displayed on the console after each operation. And yes, it works. Loggers are very useful tools. By recording how the app runs in production, they can help massively with debugging if issues arise. The key term here is in production. Logging for production and logging for testing serve different purposes. Mixing them can clutter your logs, making debugging more difficult. Let's remove the log statements and instead put a breakpoint on line 14. Control-clicking the breakpoint brings up a pop-up with a few options. In addition to disabling the breakpoint, we can also unsuspend it. When the breakpoint is not suspended, the program doesn't stop at the given line, as in the case of a disabled breakpoint, but any attached logic still executes. Clicking More reveals additional options. One thing to note is that breakpoints can suspend all program threads, which is usually what we want, or just the current thread, while keeping all the others running. However, for the purposes of our example, this distinction isn't relevant. Below the suspend checkbox, you will find the condition field, along with options for logging when the breakpoint is hit. For example, we can log a simple message that the breakpoint was hit, display the stack trace, and/or evaluate and log the result of any valid Scala expression as a string. Both the condition and evaluate and log fields support code completion, access to previously used expressions, and they can be resized for better readability. There is one thing to keep in mind though. Evaluation of conditions and log statements in breakpoints is slower than the compiled code. So, while I maintain that it's a good idea to run programs in debug mode, and it's a good idea to use conditionals and unsuspended breakpoints for logging, please be careful, especially when you put breakpoints inside frequently used loops. Now, let's rerun the test and check the console. We see breakpoint reached, followed by the stack trace and the result of the expression I added. This functionality covers most of the same debugging cases as a logger, but there's more. If I now control-click the breakpoint, notice that it's orange, not red, that is because it's unsuspended now. The pop-up shows the fields I used and allows me to make quick edits. The remove once hit option removes the breakpoint after it's triggered. It can be useful for checking the program's state at a specific moment in a loop, with that moment being described in the condition. But since the loop will continue to work for many more iterations, and we don't want to spam the output with unnecessary log statements, we select remove once hit, so the debugger will automatically remove the breakpoint after hitting it. Another useful field is disable until hitting the following breakpoint. Imagine you want to log the program's state only after it passes a specific point in the code. You can set an unsuspended breakpoint at that location and then set a second breakpoint where you want to log the details. Click disable until hitting the following breakpoint and choose the first breakpoint from the list. Now, whatever you put in the log expression will be displayed in the console only after the program passes through that first breakpoint and hits the second one. We can also limit the breakpoint's effect to specific classes or instances. Specifying a class is useful if the breakpoint is in a superclass method, but you only want it to trigger when called from a specific subclass. The instance filter offers even more control. Pause the program and check the threads and variables window. Each field has an ID consisting of the class name followed by @ and a number. Copy this number, add it to the instance filter in the breakpoint settings, and the breakpoint will only trigger when the method is called on that specific instance. Additionally, the pass count option allows you to specify how many times the program must pass the breakpoint before it activates. Again, this is good for checking the state of a loop, but only after it has already completed a couple of iterations. You might have noticed two things from our previous examples. First, I manually parse and serialize the CSV file, and second, having the file read before any user input is added isn't optimal. What if, for example, we want to update the age of our protagonists only if the number given by the user is greater than 0. This means that if the user types in -2, the program does nothing, and all that time spent reading the CSV file is just wasted CPU effort. Let's address both those concerns. In this version, I use a small library called Scala CSV. I've rewritten the read and write methods and merged the reading and deserializing into a lazy val. Now, if the user enters a number less than or equal to 0, the lazy val won't initialize and the CSV file won't be read. We can test this by setting one breakpoint before protagonist initializes and another in its implementation. Or, even better, let's step into the Scala CSV code and set a breakpoint there. I run the program in debug mode, I can immediately see the prompt. If I enter -2, the program ends without hitting any breakpoints. But if I enter 5, the program pauses. In the threads and variables window, we see a reference to this and an uninitialized protagonist field. From the debugger, we can initialize protagonists by clicking the initialize link. A pop-up warns that a breakpoint was ignored during initialization, but that's okay. The initialization succeeds, and now we can see the list of protagonists in threads and variables. Let's remove the breakpoint in the main method and run the program again. This time, when I enter 5, the program pauses inside the file csvreader.scala. Since we have access to the library's source code, the debugger treats it like our own code. We can inspect the program state in threads and variables, use all of the navigation buttons, and view the call stack in the frames panel on the left. What we can't do is edit the code. This might be another argument for using unsuspended breakpoints for logging. We can't add log statements here, but creating breakpoints is possible. The call stack tells us how we got here. We are currently in the parse next method. We came here from read next and there from toStream and so on. The lines highlighted in yellow belong to the library and the ones that are not highlighted are ours. What's more, we can both look where we came from and move back to before those steps were even made. See this little reset frame button here? Clicking it returns the program to the moment immediately before the specified step. I can even go back to the start, rerun the program, and provide a different input when prompted. There is a limitation to that. Mutable states are not reverted, meaning that if during the original run of the program some of the state was modified, it will stay modified after we reset the frame. In Scala, where we usually keep the state immutable, this is not a problem, but if you use mutable states, keep it in mind as it may lead to unusual program behavior. And that is all for today. Thanks for watching. If you enjoyed this video, look for more on our channel. You can also like and subscribe, read our blog, and talk to the development team on our Discord server. All links to these resources can be found in the description. Happy developing!